Hello guys, welcome to Makaut CSE. So in this video we will learn about the numerical integration in numerical method subject. Okay, so in numerical integration we have lots of concepts. Okay, so we already know about the concept of integration, right? So in integration we have a definite integral. Okay, so this is normally an integration, right? Integration of a to b f of x dx. So this is the normal integration process, but we can solve the same question by using some numerical methods. Okay, so how we can approach? So we have a polynomial function p of x, okay, which is similar to the f of x. So that's why we can write that I equal a to b. Just we replace f of x with p of x. Okay, so we can write this. Okay, so now the approximation of I is known as the quadrature or the numerical integration. Okay, so this is known as quadrature. Okay, so this is actually the numerical integration. So now in this chapter at first we will know about the concept of the quadrature formula. Okay, okay, and then we will discuss about the properties or some methods in this chapter. Okay, at first we will learn about, so this is the topics like quadrature formula, trapezoidal rule, Simpson's 1/3 rule and Whittle's rule. So we will discuss in easiest way possible, and also the geometrical significance and errors in each rules. Okay, and also the conditions related to each rule, and also the graphical analysis. Okay, so here at first we learn about the concept like at first general quadrature formula. Okay, general formula. How we can derive this topic? Like initially we have a integration, definite integral. Okay, a to b. Okay, f of x dx, and also we have some points like and b. This is the interval. Okay, a to b, this is the interval, and in this interval we have lots of points like x0, x1, x2. Okay, so like that, like a equal x0 and then x1, then x2, then x3. Okay, so in this way at last we have xn which is equal to b. Okay, so these are the x-axis points. Okay, so by this point we have also some values and also the length, like x1 equal to x0 plus h. Here h is the length, you can say the space length in each coordinates. Okay, like that x2 equal x1 plus h. So by this way we can write that xi equal x0 plus ih. So i's value lies between 0 to n. Okay, so by this way we have also y values. Okay, and we can write this. Okay, so y0 means f of x0. Okay, so now suppose that so by this way we can write that plus sh. Okay, so this is actually what means we integrate total, means a to b we will integrate our functions. So this is our functions and now we will integrate this. Okay, so our last point will be what? Means we start x0 and then go to up to x0 plus nh, right? This is equal to b, means our starting point x0 and ending point x0 plus nh. This is also known as a and b. Okay, so now our integration means I equal x0 to x0 plus nh and f of x dx. Okay, okay, means this is a and this is b. So by this way we know that s equal x minus x0 plus h. So integrate derivative in both side. So okay, so now we can replace. Okay, so here dx equal h into ds. So if I put here, so these are the upper limit and lower limit considerations. Means when x equal to x0, then s equal to, we calculate this equal to 0 by this formula. Okay, okay, and when x equal to x0 plus nh, so our x equal n. So by this way we can interchange our limits, upper limit and lower limit. So here lower limit 0 and upper limit is n, and we can write f of x as x equal what? x0 plus sh. Why we can write? Because by this formula. Okay, and dx equal, actually we calculate the h into ds, so h here and ds. So now this is changed now. Okay, so h into, okay, so can you remember that in the previous numerical method video we already discussed some examples like shifting operator. Okay, e to the power n f of x, we know about x plus n into h. So here just similarly we just replace, means here x0 into ds. Okay, just see this example. So we transform our these functions to shifting operator, right? So now we know about that the formula E equal 1 plus del. Okay, so by replacing E, 1 plus del is f of x0, and also we know f of x0 means what? F of x0 means y0, right? So y0 into ds. Now we will calculate the binomial expansion. Integration of n. So 1 plus s into del plus s to s minus 1 by 2 factorial into del 2 plus s into s minus 1 into s minus 2 del 3 by 3 factorial into, okay, so by this way, and last y0 into ds. Okay, so now the generalized formula after this calculation, we have I equal integration of x0 to xn f of x dx equal h into n y0. After you this you can also calculate this integration, okay, and the values, and also put limit value, okay, 0 and n. Okay, and okay, so this is the values after integration. So this is known as the general integration formula, when the interval of the integration is divided into n sub-equal spaces, okay, means x0 to xn. See, x0 to xn, we now divide our intervals into n sub-intervals, okay, so n sub-interval. Means we divide our interval into n sub-intervals, and after this interval we now integrate each part and combine this part, okay. So this is known as sub-intervals, okay. So also this formula is known as the general integration formula, okay. So this is known as the general integration formula. Okay. So at first the trapezoidal rule. Here the sub-interval is even or odd, anything, okay. So actually these formulas, the derivation, after derivation, if we put n equal to 1 here in this formula, then we get the trapezoidal rule, okay. Then we get the trapezoidal rule. See, don't need to remember the formula, because you can derive each formula, okay, in your own side. At first, see the points x0, okay, x1, x2. So by this way, after some times we will reach xn, okay. So at first x0 to x1, see these intervals, just x0 to x1. So integration of x0 to x1 and f of x dx. So this is the integration from x0 to x1. So the formula said that for trapezoidal rule, this is plus y1, means for x0 and x1 we have y0 and y1, okay. So for 2 points, this is our main normal formula. So by this way, the sub-interval means what? Here sub-interval is 1, x0 to x1 means 1 interval. So after this, x1 to x2 means another 1 interval, x1 to x2, f of x dx. So by the same process, we have y1 plus y2, because for x1 we have y1 and for x2 we have y2. So by this way, if we approach, means x0 to x2, because we already calculated x0 to x1 and x1 to x2, now we can calculate x0 to x2 directly by addition of these two, means x1 to x2, f of x dx. So x0 to x2, so we can divide this by x0 to x1 plus x1 to x2, f of x dx plus f of x dx. So by this way, h by 2 y0 plus y1 plus h by 2 y1 plus y2. See, the last two are separate, means y0 and y2, plus y1 is repeated, like, so 2 into y1. So by this way, for generalization, x0 to xn point, okay, we have formula, means the terminal points x0 and xn, the terminal points x0 and x1, just write y0 plus yn and plus 2 into, and the another points, means after y0 we have y1, y2 plus dot dot and plus before the yn, means y of n minus 1. Simple. You can see from here these examples. Okay, so these are the points. So this is the composite trapezoidal rule. Okay, just say very simple. Okay, and you can derive in the examination also by this formula. Okay, so for trapezoidal rule, the degree of precision is 1 and the error is this. Okay, so you can remember this formula. Here you can see the geometrical significance of trapezoidal rule. Okay, so in this case we have a curve f of x, and this curve actually create an area like x equal to x0, this line, x equal to x1, this line, the curve and the x-axis. So this create a area, right, and this area is the approximation of trapezium area. Means this area, how we can calculate by numerically? See, there is some trapezium created. So this trapezium's area is approximately equal to the curve's total area. So now we need to calculate the area. So this trapezium, that's why trapezium rule is trapezoidal rule is known as the trapezium rule. Okay, so trapezium B, A, C, D. So here one trapezium. So the trapezium's area and the curve's integration area, these are the equal. So this is the geometrical significance of trapezium rules. Okay, so the trapezium's BACD's area is equal to the area of the curve for the functions. So this is the trapezium. Okay, so here in this case the trapezoidal rules conditions means even and odd number of equal subintervals. Means what? See, means x0 to x1, x1 to x2 and x2 to x3. So here intervals, how many intervals? 1, 2, 3. So that's why 3 interval. And why equal? Because we don't directly jump to x0 to x3. We jump step by step. Means x0 to x1, one step, x1 to x2, one step, x2 to x3, one step. That's why this is equal intervals. But in this case this is even interval. Why even? x0 to x1 and x1 to x2. How many interval? 2 interval. That's why odd number of intervals. Okay, even number of intervals this is. Okay, so here is an example. Okay, so you have an interval 0 to 1 and h equal 0.5. Sometimes the h is not given. In that case you can from your own side find out. Okay, so at first don't directly solve this question. At first you need to calculate the sub intervals. Means here 0 to 1. Okay, so 0 to 1, how you can go directly to 0 to 1? By using h equals 0.5. So at first 0 to 0.5, then 0.5 to 1. So here the length is 0.5, the length is 0.5. That's why this is h. So 0 to 0.5 and then 0.5 to 1. So in each step you need to go h length. Okay, so here the two sub intervals. So we can use the trapezoidal rule. So trapezoidal rule says what? Here the integration of 0 to 1 dx by x. So at first you need to find out the values. Okay, for x0, for x1, okay, for x2, because here is 3 points, x0, x1, x2, and according to that you will get y0, y1 and y2. Okay, so x and f of x, so 0, 0.5 and 1, and according to this if you put x equal to 0 in this case and this function f of x, here f of x is okay, so you will get 1, 0.6667 and 0.5. Simple. So for trapezoidal rules formula, at first y0 and then yn here 1, and then the others points. Here others point mean what? We have just 3 points, y0, y1, y2. So y2, that's it. So you can put the value. So y0 is 1, y1 is 0.6667 plus 2 into y2 see y1 and y2 0.5. okay, see the y0, y1 and y2, this is y2, right? This is y2, so this is y1. So here the values are y2 in 0.5 and then 2 into 0.6667. so after this you can solve this question and the values will be 0.70835. okay. So now the Simpson's 1/3 rule. Here the condition is that that n equal the multiple of 2, means the sub intervals 2, 4, 6, 8. okay, means x0 to x2. So directly x0 to x2 we can go by this Simpson 1/3 rule, because x0 to x2 we have how many number of sub interval? x0 to x1 and x1 to x2. So that's why the 2 sub intervals, and 2 is what? 2 is the multiple of 2. So at first x0 to x2 we need to calculate. So this is the formula at first level, x0 to x2. So the next level is what? x2 to x4, means x0 to x1, x0 to x2, 2 intervals, and then after that x2 to x4, and after that x4 to x6. okay, by this way we will reach xn. okay, so this is the general formula at first level, second level, and up to generalized formula. y0 and y1 are the terminal points, so we separate this, and the 4 into the odd numbers y1, y2, y1, y3, y5, and also 2 into the even numbers, means y2, y4, y6. okay, so this is a generalized formula. And the geometrical significance for this Simpson 1/3 rule is, see, we have a curve, and the curve's area is equal to the parabola's area. So actually this represents the equations of a parabola which passes through the 3 points, means x0, y0, x1, y1, and x2, y2. So that's why the parabola's area and the curve's area is similar. So this is the geometrical significance in Simpson's 1/3 rule. okay, so the degree of precision means the accuracy is 3, and the errors formula for in this case is, and you can see the error symbols. okay, so the main conditions for Simpson 1/3 rule is the sub interval is the multiple of 2. okay, so sub interval is multiple of 2 in this case. okay, so here in this case we solve one example. So here we have a function f of x equal to x by x plus 1, and we need to calculate up to 3 significant digit by using the formula, the Simpson 1/3 rule. So now our first initial is x equal to 0 and then x equal to 1. So you can imagine that we need, or we will apply the Simpson 1/3 rules, right? So the sub interval will be the even number. So we can divide the sub interval in 2 parts, 4 parts, 6 parts. So don't need to higher level parts. So here you can use the 4 parts. okay, n equal to 4. n equal to 4 mean what? We divide our interval in 4 parts: 0 to 0.25, 0.25 to 0.50, 0.50 to 0.75, and 0.75 to 1. So length is what? 0.25. In each case add the 0.25, you will get 1, or you will reach 1. That's why here h equal to 0.25, and n is what? 1, 2, 3, 4. 4 sub intervals. okay, so this is the formula and this table for x and y values by this function. If you put x equal to 0, 2.5 in this function, you will get according to the y values. So you can put, and this is the answer, but up to 3 significant digit. That's why 0.30675 up to 3 significant digit. But now we will neglect this portion, right? But before that you need to check this number is what? Greater than 5. So that's why when you remove this portion, add 1 in this number, means 0.306 plus 1, 7, 307. So this is the correct answer. okay, up to 3 significant digit. So now we will discuss about the Wedel's rule. Wedel's rule is actually the concept when the n is the multiple of 6, means 6, okay, 12, 18. These are multiple of 6, right? And also by this way you can calculate when the subinterval is actually the multiple of 6. So by this way, x0 to x6, 6 subintervals, means x0 to x1, x1 to x2, x2 to x3. By this way, 6 are subintervals, okay. So x6 to x12, 6 subintervals. So by this way, at first x0 to x6 we will calculate our integral. So this is the formula. How you can remember? See, at first you need to just write y0 to y6, because here x0 to x6, that's why y0 to x6, y0, y1, y2, y3, y4, y5, y6. And remember this trick, means 1 5 1 6 1 5 1. So according to this is a coefficient, okay. 1 means we don't need to write, 5 means we need to write the 5 before y1, 1 don't need to write, 6 here, 6 into y3, okay. By this way you can remember. In the next step, x6 to x12 you can write from your own side, means 6, x6 to x12 means y6, y7, y8, y9, y10, y11 and y12. See, 1 5 1 6 1 5 1 means 5 here, 6 here, don't need to write here, 5. By this way, so after summing up or after composite these two, you can integrate x0 to x12, okay. So the generalized formula for this, so this is a generalized formula. So this is heavy, or this is very difficult to learn or remember this formula. Don't need, because you can calculate from your own side, right? So in examination you separately can form these formulas, okay. And after this you can combine these two formulas. When combined, you can create your own formulas, okay, for Wedel's rule. And this is already the same, okay. So here you can see the degree of precision, means the 5, and the errors, okay. So this is the examples. You have given functions and you need to integrate 0 to 1, and using the Wedel's rule. Wedel's rule say that the interval will be multiple of 6. Here 0 to 1. So we will divide our intervals, okay. Here we can consider n equal to 6, because start from 6, okay. So if n equal to 6, how you can calculate h equal the upper limit minus lower limit by n. So 0 to 1 we will divide our parts in n. So you will get the each part, means 0 to 1 by 6, 1 by 6 to 1 by 3. How you can approach, means see, 0 to 1 by 6 means 0 plus 1 by 6 here, and after that 1 by 6 plus 1 by 6, you will get the 1 by 3 by this way, okay. So each case add h length, so you will get the points, and according to that you will get the f of x value. So now if you put the formula in the Wedel's rule, you will get the values like 3 into by 10 into h means 1 by 6, okay, into bracket y0 means 0 and y0 is 1 and y1 is 0.5. After this, if you check the formula, means y2, y4, y8, okay. So here 0. So by this way, after putting the values, you can get the 0.7854, okay. So this is the numericals integration portion. We will solve one example for each methods, okay. So you can prepare for geometrical significance, the degree of precision for theoretical question, okay, and the graphical analysis for each methods, and also the numericals problems, okay. See, when you calculate the value of n and h, at first see the methods and then calculate the h, okay. H equal the higher minus lower by the value of n, so you will get the value of h also, okay.